Well, hello. Hello, everyone. It is Wednesday night, October 12th. It's actually 7:54. I've been hanging out to see if anyone's going to join me, and it looks like a resounding no. But one person did send in some questions, so we will go over those questions, and hopefully it answers everyone's questions. It's really important that you use this time because this is a major resource to you. At least I think it is. And I hope that in the future we can have more people attending these meetings because it's a little bit of a missed opportunity for everyone. Okay, here we go. So here we go. Hopefully sound is all good for you guys on this. All right, I'm going to share my screen and launch our homework assignment. Screen. And we're going to go to our Canvas page here. Launch your homework assignment. Here we go. All right, so this is all about the binomial distribution. And our questions are, and I'm going to make sure here real quick, I'll pop up to my own math and make sure that I did not leave the default to shuffle. Otherwise, I will be answering the wrong questions and that will be bad. Let me just double check here. Number 3, chapter 4, discrete distributions, settings. Good, we're not shuffling, so we should be all good. All right. So the first question we had was question number 4. The manufacturing has a 3% defect rate. 9 items are chosen at random. What's the probability at least one will have a defect? Well, we already know from our other work last week how to calculate at least one. Remember that at least one is not none. Again, that's a really important concept I hope you all get, that if we have 9 items chosen at random, so we have 9 items chosen at random. Right? Think about the number of items that could be defected. I could have 1 defect, none defect, 2 defect, 3 defect, 4 defective, 5 defective, 6 defective, 7 defective, 8 defective, or 9 defective. These are all the possibilities of defective, and each one of these has its own probability. And since this is 100% every possible choice, then when I add these up all together, it has to equal 1 because it's a discrete probability distribution, but also because it just makes sense. If I take every possibility that there possibly is and add them up, that's 100% of the possibilities. That's 1. Right? So they want at least 1. Well, at least 1 is 1 or 2, add those 2 together, or 3, or 4, or 5, or 6, or 7, or 8, or 9. The only one I didn't add up was 0. So all of these add up to 1. So if I subtract the one I didn't add up from 1, that will leave this. So the probability of at least 1 is equal to 1 minus the probability of none. So what I need to ask myself is, what's the probability of no defects? Well, in this problem, in my problem, it says I have a 3% defect rate. So if I take 3% defect rate, probability of 3% defect rate is going to be, no defects would mean the first one's not defective. That's 97% chance of that happening. And the second one's not defective. And the third one's not defective. And I would go all the way up to the 9th one not being defective. I would multiply all that up. So this would be 1 minus 0.97 raised to the 9th power. So if I do that on my calculator, 0.97 raised to the 9th power. That is 0.760231. And take 1 minus that. And I get 0.2397. So at least one defect would be roughly 24%. That is what it would be. It's 3.976. So to 4 decimal places, it would 0.2398 to 4 decimal places. So that is question number 4, at least one defect. All right, the next question we have is question number 6. All right, so let me share my other screen here for you. Question number 6, multiple choice questions have 3 possible answers, one of which is correct. Assume that you guess answers to 4 such questions. Use the multiplication rule to find the probability that the first 3 guesses are wrong and the 4th is correct. Define the probability of wrong, 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 correct, where C denotes the correct and W denotes the wrong answer. So they want us to find this. And then it said exactly one correct answer. I'm going to do this a couple different ways. I'm going to do this using the probability multiplication rule, and then I'm also going to use the binomial formula using the binomial distribution, because we have 2 possible answers. They're all independent. Getting the first question right doesn't give you any better chance of getting the second question right, and so on. So let's start using this way. All right, so our first question, probability of getting wrong, 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 correct. Well, I have a 2/3 chance of getting the first one wrong, and a 2/3 chance of getting the second one wrong, and a 2/3 chance of getting the first mix wrong, and a 1/3 chance of getting the last one right. Right? So it would look like this. Again, we're just guessing by random. So that is going to be 2 times 2 times 2, which is 8 over 81. So 8 over 81, whatever that is, as a decimal, round it to 4 places. Now it wants to know exactly one right. Well, I could get the first one right, which would be 1/3 times 2/3 times 2. Oh, look at that. Also 881. I could get the second one right. You can see this is also going to give the same numbers, just mixed up order, 881. And I could get the third one right, 881. You'll notice there's 4 different ways I could get exactly one right. So this would be 4 times 8 over 81, which is 32 over 81. Just a decimal is the 4 places is this. All right, now let's use the binomial theorem. The binomial theorem is NCR times P to the R times Q to the N minus R. And this is the definition to the binomial theorem. Let's go through this. I have 4 things, and I'm getting one of them right. 4 questions, I'm choosing one. Probability of me getting a question right is 1/3, and I'm getting one of them right. The probability of me getting it wrong is 2/3, and I'm getting 3 of them wrong. So this is counting the number of ways that I can get the number of ways I can get one right out of 4 questions. And this is the probability of getting one right out of 4 questions. Probability of getting one right implies I'm getting 3 wrong. So I have to do that. 4 choose 1 is 4 factorial over 3 factorial times 1 factorial times 1/3 to the first power times 2/3 to the third power, which is 8 over 27. This ends up canceling out and ending up being 4 times 8 over 81, which is 32 over 81. Now, your calculator also has a binomial button, and I like to show that to you now. So if I go to this second distributions, we use this button a lot throughout the course, second distributions. And I go down to the one way at the bottom. It says binomial PDF. That stands for binomial probability density function. I hit enter, and it'll say, how many trials do we have? Well, how many questions are we answering? We're answering 4. We're answering 4 questions. What's the probability of getting one of those trials right? Well, it's 1/3. So I'm going to put in 1 divided by 3. Right. And it says, how many are we hoping to get right? What's the X value? I'm hoping to get 1 right. And I hit enter. And look at it, just puts that 0.3901 right up there for me. I'm going to pop back to that question about non-defective. Okay. Okay, remember that at least one non-defective? This calculator will actually calculate that for me as well. So remember from that question, look at my calculator right there. It was 23% for that one, at least one defective. If I go to second distribution, and I go down to where it says binomial CDF right there. That stands for binomial cumulative density function. Cumulative density function. So in binomial CDF, cumulative stands for adding up several options. And in this case, I am going to click that, and it gives me these choices. All right. And let's say I wanted to know what's the probability I get 4 or more defective items. So I know that I had 9 things I was picking. Probability defective was 0.03. Right? If I choose 4 or more, this is going to give me everything up to the number I put in here for the X value. So if I put in 4, it's going to give me 0, 1, 2, 3, 4. So what I really want to put in here is 3, because 4 or more would be everything but 0, 1, 2, and 3. So I'm going to put 3 here. I hit paste. And look at that. That's the probability. We have 3 or 0, 1, or 0, 1, 2, or 3 defective items. So 4 or more would be 1 minus that. Which would be 0.9. So the difference between cumulative density function and density and probability density function is whether I'm picking exactly 1 or if I want to add up from 0 to that number. Let's take a look at some of the other questions. Number 7 is the next question. It says, all right, a company prices its tornado insurance using the following assumptions. in any calendar year, there can be at most one tornado. In any calendar year, the probability of a tornado is 0.04. The number of tornadoes in any calendar year is independent from the number of tornadoes in any other calendar year. And using, I'm looking at number 7. Using the company's assumption, calculate the probability there are fewer than 2 tomatoes in a 12 in a calendar year. Give your answer as a fraction to 4 decimal places. So fewer than 2, that's 0 or 1 tornado, right? So we got a 4% chance of there being a tomato. And this is a 12-year period. So I'm going to use the binomial function on my calculator. So I'm going to go second distribution. Okay. I will also write out the formula for you after I do it this way. Okay. All right, this is fewer than 2. 0 or 1 is fewer than 2. So I'm going to go binomial CDF. Number of trials, 12 years. Probability of having our tornado, 4%. Value, X value is 1 because it's going to be 0 or 1. I'm going to paste, hit enter. 91% chance, according to this, that I get that fewer than 2. Yeah, 91.9. See it here. Okay, now let's write the formula out if you wanted to do this longhand. All right, so we would have 12 years, choose 0 tornado years. So there's no tornado years, times the probability of getting a tornado raised to the 0 power, times the probability of not getting tornado for all 12 years. That's the probability of getting 0 tornadoes in 12 years. Plus 1 year, because we want fewer than 2, so that's 0 and 1. 12 years, calculate 1 tornado. Six to the 11. 1 year we have a tornado, 11 we don't. I calculate this out. All right, 12 choose 0 is 1. There's only one way you can choose 0 things. Times 0.04 to the 0 is 1. Times 0.96 to the 12th is 0.612709. So far we have 0.12709 plus 12 choose 1 is 12. There's 12 ways you can choose one thing from 12 times 0.04 times 0.96 to the 11th is times 0.03269333 times that by 12 times that by 0.04 plus 0.30635. Add these two numbers together. And not come out with what we should have. This gave me 0.94. Oh, because I added the wrong two numbers in my calculator. Let's try that again. 0.612709 plus 0.30635 equals, there we go, 0.91905. Right. Okay. It's exactly what we wanted. So touch a rounding error, but far past 4 digits, so we're fine. So that is how we would do those problems by hand. Now, fun fact, sharing a new screen here. Aren't we having such a good time together? Me and myself? Yes, I am. All right. If I share this screen with you, look at this. Hello, my good friend Minitab. Like if I go to calculator, you're like, oh, look, my session expired. That's because I'm all by myself. All right, now got my Minitab back up. I'm going to go to calculator, and I'm going to store in C1 again. And I am looking for binomial. Let's see if we can find it. It's not there. You're not. Go to calculator, go to probability distributions. And let's do a probability density function would give me 1. Cumulative density function will give me multiple. Let's do that one. Remember, I want 0 and 1. So, all right. Oh. Let's try this again. Calculate probability density function. To choose my binomial function. Right. My value, I want to go up to 1. I'm going to put 1 there. Number of trials, we have 12 years. Probability of getting a tornado is 0.04. Let's see what we get here. There it is. Probability that is less than or equal to 1 is 0.919065. That's cool. Let's play around with this Minitab a little bit more. Probability distribution function. And go to probability density function again. Not cumulative this time, just density. Value 1. Need to choose the right distribution, binomial. Number of trials, 12. And event of probability, 0.04. There's that 0.31 that we added together, or 0.306. Okay, cool thing. Look at this. What if I fill in this column with all the possibilities? 0, 1, 2, 3, 4, 5, 6, 7, 8, not 6. Excuse me. 5, 6, 7, 8, 9. Computer's got a little bit of a lag today. 11, and 12. And then I went up here to data, calculate probability distribution. Again, instead of choosing single, I'm going to choose a column of values. My values are in C1. And number of trials, 12. Okay. Look at this. It gives me every probability distribution for each number. 0 is 61. We calculated that ourselves. 1 is that. Goes on down here until the probability is so small, it's essentially 0. So anyway, that's a cool thing that Minitab does. Your calculator also does that. So now we have a couple more questions from this homework. Next one, we did 7. 8. A dragon on a fictional planet of Pern lays eggs. They're either green or yellow. Sounds like a binomial choice. Green or yellow, 2 choices. The biologists have observed them over the years that 33% are yellow and the rest are green. Next spring, the lead scientist has permission to randomly select 57 dragon eggs to incubate to consider all the possible samples of 57 eggs round to this. Compute the mean number of eggs. So, as you might have seen in your book, the formula for the mean number of eggs is mean, the number you have times the probability to happen. We want the mean number of eggs or yellow eggs. The probability of it being yellow is 33%. We're taking 57 times 0.33. Makes sense. We're expecting the mean is the expected value, the average, what we expect. We have 33% that are usually yellow, so 57 times 33 are what we expect to be the average. Compute the standard deviation. The standard deviation is the average distance away from the mean. Haven't covered that a whole lot in this class yet. There is a problem with this book, and I might have to deviate a little bit from the book because of that. The standard deviation is the average distance away from the mean. So they're asking, like, how much does this vary? If I took multiple samples of 57 eggs over and over and over again over time, what's the average number I'd be off from this mean? And to calculate that, you take the square root of n times p times q. And then calculate the variance. The variance is just the square of the standard deviation. So whatever you got from this, which is just n times p times q. P is the probability at 33% of yellow eggs. Q is the probability of not getting a yellow egg. So getting a green egg, which would be 67%. That is how you do that problem. Rectify that and according to Master Foods, okay, we did this very similar problem last week. We did this problem last week. They're just now saying you could use a binomial distribution for this now. It's the same exact thing. At most 2 are of the 5, so 0, 1, and 2. Again, that's going to be binomial CDF up to 2, or you could calculate 0, 1, and 2 and add them together. Hopefully, after the ones that we've done, that kind of makes more sense now. Looking down at 15 and 16. Again, this is a binomial distribution where the number to choose, so n is 4, probability of being defective is 7. So what's the probability at least 1 is defective? Well, we know that that is the probability of 1 minus none defective. And none defective is 4 choose 0, which is 1, times 0.07 to the 0 power. So we have 0 defective times 0.93 to the 4th power. Okay. So 1 minus this answer that we get here, which is consistent, exactly 2. Change this to 2. Change this to 2. And change this to 2. 2 defective, 2 not defective. Probably less than 2 would be 0 or 1. We calculated 0 here. Calculate 1. Change this to 1. Change this to 1. Change this to 3. Yeah, 1 defective, 3 are not. And that with what you get to 0. More than 1 is 2, 3, 4. So you could calculate 2, 3, and 4 and add them together. You already have 2 here. You could calculate 3 and 4 and add them together. Or you could acknowledge that if you have 0, 1, 2, 3, and 4, and in part C, you got less than 2, and in part 3 is more than 1, which is 2 or more, then these two things add up to 1. So if I calculate this in part C, if I go 1 minus part C, it would give me letter D. Right. And moving down here. Right. Sells cookies packs of 5, the probability distribution is okay. If this is going to be a discrete probability, this bottom row has to add up to 1. These have to be all the choices. There can be no missing choices. So figure out what number that is added up to 1. To find the expected number, right, for a discrete probability distribution, you take, right, x times the probability. So the expected value is equal to x times p of x. So, and then you add those all up. That's a sum sign. That means add them all up. So it takes 0 times 0.024 plus 5 times 0.36 plus 10 times 0.09 plus 15 times whatever you got there for 15 plus 20 times 0.07. This would give you your expected value, also known as your mean, which we write as mu. That's shorthand for mean. All right, now it wants to find the variance. The variance is the sum, add up, x squared times the probability of x minus the mean squared. That's how you calculate the variance. Again, this is a measure of how far away from the mean that we expect. If I take the square root of this, I would get the standard deviation. So what I would do is I do the same thing I did here, except for I square all of this, squared, 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 and then I take whatever number I got from part B, whatever number that is, squared, and subtract it. And that would give me the formula for the variance. All right, so that's how you do that problem. And number 23. So this one is really just like reading, oh no, this one, sorry. Okay, so this says a pharmaceutical company receives large shipments of ibuprofen tablets and uses this acceptance sampling. So it takes a sample of 30 tablets and it will set the whole batch if at most one, if there is at most one that doesn't meet the requirement. So you get to have one. Otherwise, no good. So, uh-oh, there we go. I'm going to share this. Okay, so we're going to take a sample of 30. And if we get 0 or 1, we're going to accept it. So here's the probability of getting 0 bad ones. If 5% are bad and 95% are good. Plus, we need the probability of getting one bad one. If one is bad, and 29 are good. So if I calculate that, this part right here, doing it by hand, 1 times 1 is 0.05 to the 0, times 0.95 to the 30th. And my calculator, 0.95 raised to the 30th power. Little bit of rounding error there. Right, and this one would be 30 times 0.05 times 0.95 to the 29th. Right, so I times that by 30, answer 0.05. And this number is 0.338933. I add that number to my first number, and my final answer will be 0.53542, so on. All right, now I could also do that using my calculator. I could say second distribution, blue button, and then the distribution button. Go all the way down to the bottom until I see binomial CDF. I've got 30 pills I'm testing. Probability of one of them being defective is 0.05. Our X value, we want up to 1, so 0 and 1, so I'm going to use 1 and hit enter. And there it is, same exact number, 0.5535. Or if I'm feeling spunky and I want to use my mini tab, I can go to my mini tab screen. And go to calculate probability distribution, cumulative because we want at most 1, so 0 or 1, so it's cumulative. We are adding numbers together. A single value 1 binomial. That's the right distribution. It's a binomial distribution. It's either defective or it's not. Number of trials, we tested 30 pills. Probability of any one of those pills being defective is 5%. Value 1, hit OK. And there's our 0.5535. So that is that one. All right, well, hopefully everyone is getting this and understanding the lab. If you have any other questions, let me know. So next week is our first test, and I will be posting some information about getting your proctor. But you are going to need to have a proctor for next week's test. We're already into week 4. Seems surprising, but it's true. So I'll be posting information by Friday of how you need to get your proctor. And we will take our next test next week, our first test. I hope you guys all have a great week, and we will be in touch. Please email if you have any questions. And hopefully you guys are all getting this. Have a great night. Try to tune in next week so I'm not lonely. Thanks. Bye.